A right circular cylinder, all that means is it's a cylinder that sort of goes like vertically up. It's not a cylinder like that. That is technically a cylinder. And it's contained within a sphere of radius 5 centimeters in such a way that the whole of the circumferences of both ends of the cylinder are in contact with the sphere. Like here, here, and as it goes around, it will be. The diagram shows a planar cross-section through the center of the sphere and the cylinder. Find the maximum possible volume. So what we got to do here is get that radius involved. And I can start from the center and draw a line that goes to that very corner where they meet. I know that's 5. And then the radius of my cylinder I can call r. And then I could call this, I'm allowed to call this h, or I could call it half h. I decided to call it half h. You may call it whatever you like, really, but yeah, so the whole height is h. I've just got to remember that along the way. And then I can write down two things, actually, a relationship between r and h that just appears because of Pythagoras' theorem, and the volume of the cylinder. Let's write down the volume. It's going to be pi r squared h. And if I want to find the maximums, I want to somehow get it in terms of one unknown, and that's where the second bit comes in. We can link them all together. R squared plus a quarter h squared is going to equal 25. Now, if I make h the subject, I'm going to get some square roots. So I decided to make r squared the subject and substitute in for that. R squared is 25 minus a quarter h squared. So therefore, V equals pi 25 minus a quarter h squared times h. Brilliant. That becomes 25 pi h minus a quarter pi h cubed. And I've managed to get the volume in terms of just one variable, the height. So this would have some sort of cubic graph, and I want to look for the maximum, so stationary point. dV by dh, I nearly did the x then, is going to equal 25 pi minus 3 quarters pi h squared equals 0 for stationary points. I can cancel out the pi's, rearrange it, so 3 quarters h squared is 25, so h squared is going to equal 100 divided by 3. And I'm pretty much there at this point, so h would equal 10 over root 3. And if I want to find the maximum volume, I'm going to substitute it back in. We don't need to look at the second derivative here. It kind of, you can make a really, really thin cylinder and get a very, very small volume. But this is going to be the maximum. Hopefully you're convinced by that. Okay, so let's put it back into which one? Maybe this one here that's been expanded. So max V is going to equal 25 pi times 10 over root 3 minus a quarter pi times 100 over 3, that's my h squared part, times 10 over root 3. Let's get it all over 4. Actually, it becomes 100 pi over 4 here. And then I can, or maybe I should make it over 12. I should just change my mind to 300 over 12. Because now I've got a common denominator of 12 root 3. And on the top, I will get 3,000 pi, and I'll be minusing 1,000. Sorry, that was meant to be 3,000 pi. 3,000 pi minus 1,000 pi, and I put it all together, which is 2,000 pi over 12 root 3. I could divide through by 4 now. Oh, maybe I should have done that earlier. So 500 pi over 3 root 3. And the final answer is they've rationalized the denominator, so let's do that. 500 root 3 pi divided by 9. And that will give us an answer of E.